Hello YouTube, De-bodgery here. So an add-on to the ViaAir. Um, I'm sure you can see the gap in there. I'm just holding it together with my fingers. So if I take this apart, the um, the valve body sits in these four little slots, and it even has a fixed slot or key, I guess you'd call it, so you can't put it in backwards. So it only goes in one way, which is kind of cool. Somebody was actually thinking. But what they didn't do was they didn't fill the gap between the head and this piece so that they actually make mechanical contact other than via these four little posts right here which keep them apart. So you really don't get any conduction of heat away from the head to this at all. And of course, this whole piece is just a loose fit around here. I'm not really worried about the cylinder. That's not what gets hot. It's the compression of air, which all happens up inside here. That's where all your heat is. So if there's an area that's going to have heat buildup that's going to create more problems than anything, it's going to be all up inside there. So dumping heat away from there as much as you possibly can is in everyone's best interest. So this really should have made better mechanical contact with the top, or the head, I guess you could call it, so that the two of them can work together to dump heat. Because as it is right now, there's a sizable gap. I would say a 1/16 of an inch, a millimeter and a half, something like that, gap between the two. So no heat from here gets to here at all to do any good, which is kind of disappointing. I think probably what I'll do is I have some thermal gap filler, which is basically this silicone-based material, and I can put it all on this surface all around here so that it mates up with the tops of those fins, and that will help significantly. You know, even like in here, if I put the valve body back in here, it goes something more or less like this. It doesn't touch at all. So there's not even heat transfer through this valve body from the top, other than at the very ends of these keys. So there's not much heat transfer to this piece of metal, which is why when I was looking at it on my laser temperature meter, I wasn't seeing anything, because, well, it's not happening. If anything, this transfers heat ever so slightly from the top of the crank assembly, so from here, because at least the piston touches that part. But that's it. Otherwise, there's no transfer of heat to this piece hardly at all. It's all purely air transfer, which is massively inefficient. So I'm probably going to fix that just a little bit. This piston sleeve, it was slightly oiled inside, and so it has some of the same kind of oils that are typically used on O-rings. So I've added a little bit more inside there because it was almost the point of being absolutely dry. There was no oil here at all. So I've added just a little bit on there. I don't know if that's going to matter or not, but they've done a really good job. I don't know what this is. It's not steel, I can tell you that much. It won't attract a magnet at all. So it's got to be some kind of a brass or something like that. But yeah, it's slightly oily. It's definitely very slick. I don't think it's plastic either. I'm not sure quite what it is. It's definitely cool, though, to the touch if you leave it alone. So it's metal. But yeah, I'm still pretty happy with the design of this thing, other than, a little bit more convection, or a little less convection, a little bit more conduction would have been a good thing from here to the rest of the parts, so that you got a little bit more heat transfer from one place to another. But this is easy to fix, and nobody's hiding anything. Not really. It's just simply not quite up to 100%. Whereas, with the tire well, the plastic shrouds made you think you had cooling, and you didn't have any, in fact, at all. So this is still a significantly superior pump in every possible way to the tire wells. So I'll fix a couple little details on this thing. Probably what I'll do, in fact, is on the bottom of this, I'll put some thermal glue. So when that clamps back together again, it's going to mate up to this surface right here pretty well. Put some thermal glue around the bottom of the piston, so that all those things, they conduct heat together. And then, and I should point that out too. So yeah, somebody really thought about this. So there's keyways, or little keys here, notches or something, and in the top of this assembly, they've done the same thing. Everything here is all assembled with M4 screws. It's all cast metal parts. Somebody did a pretty decent job. I would have to say that it could have been better, and I know that these used to be an actual aluminum heatsink rather than this cast whatever it is. So it used to be better, but it's still not horrific. In fact, let's see, this magnetic? No, it's not magnetic. It's some kind of aluminum or cast zinc or something like that. But still, this is way, way better. You know, even though it's been value engineered to a certain extent, still significantly better than the tire well.